Hi everyone, this is a quick revision on vectors, addition and subtraction of vectors. So our example is a car travelling east at 20 meters per second turns 90 degrees anticlockwise and accelerates to 30 meters per second. Calculate the change in velocity. So first of all we can just draw a quick diagram. So this is our initial and then our final up there. We'll just make this a bit shorter because final velocity is actually larger. It's 30 meters per second. The reason why the final is going up is because it's turning anti-clockwise by 90 degrees, which is another way of saying left or north. So it's going north from where it originally was. Now when we calculate the change in something, the change is always final minus initial. Like if you worked out the change in temperature for the maximum and the minimum of the day, you'd go maximum minus minimum. So we're going to do the same thing. So this means when we do this with vectors, we need to redraw our diagram. So we want to draw, there's our final velocity vector. And then we're going to draw our initial one this way. And then we have our final minus initial. So then our change will be the resultant vector that comes up from the bottom and to the top. And we often denote the resultant or the change vector with the two arrowheads. And we also need to put our angle in there because we want to calculate the angle. Okay, so this actually gives us a right angled triangle. So you can use Pythagoras' theorem because we want to find the long side. So just in case you have forgotten it, a squared plus b squared equals c squared. So therefore c, let's take the square root of the other side, equals the square root of a squared plus b squared. So this means that our change velocity will equal the square root. Doesn't matter which way around you write these because it's just addition. So 20 squared plus 30 squared, which gives you, if you put that in your calculator, you should get 36.1 meters per second. I forgot to point out earlier that the reason why we wrote the initial velocity, or we drew the initial velocity vector the other way, is because we wanted to have the negative initial velocity. So then we can get final minus initial. So we turn the initial vector around the other way, and that just helps us with our addition. Okay. So we've got the value, the magnitude of the change in velocity, but now we need to work out the direction. So to work out the direction, that's when you need to use tan, because tan is opposite over adjacent. And so this will give us our direction, so I'll just write this here. Direction will be given by inverse tan. Opposite is 20, adjacent is 30, so it'll be opposite over adjacent, which equals 33.7 degrees. So you, for physics, you do need to remember SOHCAHTOA and your trig identities. So it's worth revising if you feel that you need to. Okay, so we've worked out the magnitude of the change in the direction. So now we say, so therefore the change is 36.1 meters per second in a direction of north 33.7 degrees west, because this direction up here is north. So remember that when you write the bearings, or the angle, that is always north and then west or east, or south and west or east, so we never write south 15 degrees north, for instance. Okay, and that's the end of the question. Thank you.